9 is less than 54 over x is less than 14. And then you would still have to do a bit of algebra, but you would know that x is between 54 over 9 and 54 over 14, which is like maybe a tiny bit shorter, but yeah, a lot of ways work. That one definitely works too.
Oh, yeah, that's true. Okay. Yeah.
Angela, I'm not sure if the recording is going to be on the YouTube channel. I don't know.
I don't know. I think you can ask Professor
I
Lowe about
think
it.
they said something about like not having a recording, but I don't exactly.
Oh, Professor Lowe said that he was asking us permission if he could put this on the live stream for YouTube and Facebook.
Oh, okay.
So I think the option is there. But I'm fine with it. I think we can put it on there.
Yeah, me too.
Okay, sure.
Okay.
Um,
Well, I guess I'm moving on to this problem then. So the sum of n consecutive numbers is divisible by n. Oh, that's interesting. I really like this problem. Okay. So, I mean, I'm just going to like maybe start by trying numbers and like seeing which numbers work. Okay, well, let's just say I immediately know that like D works. Like not even really like doing the problem. I kind of can see that like D probably works. And the reason why D probably works is because so if you're looking like mod of prime, or I shouldn't say mod, but like mod, so like mod P basically means remainder when divided by P. It's just like a shorthand way of saying it. So, oh wait, okay, Lainey, you said if n is odd, the consecutive numbers are just like multiples of the middle number. Okay, you're right. So like you're basically saying, like for example, if we had like 3, 4, 5, 6, 7, and this is like an odd number of numbers, so it has a median. So the sum equals 5 times 5 because it's just the median times the number of numbers. Wait, oh my gosh, wait, okay, I get what you're saying now. Because like Lady is basically pointing out that as long as the set of numbers has a median, the sum is going to be divisible by the number of numbers, since sum equals average times number of numbers. And if the average is an integer, and the number of numbers is an integer, then the sum is clearly divisible by the number of numbers. So like Lainey is definitely right. It definitely works for all odd n. And actually it does work for all prime n, but guess what? Odd n is stronger than prime n. So I'm gonna circle odd n instead, because if it works for odd n, then it obviously works for prime n. And it definitely doesn't work for 2, because like if you tried 2 and 3, it wouldn't work for 2. So I'm guessing the answer is odd n, but yeah, this problem is actually kind of hard.
I got odd too. Like I set it up like so like this is the formula for like some
Oh,
consecutives, right? And so you know that's divisible by n. So like it's a multiple of something n, right? And then you like do stuff. I mean, I divided here by n, but you know that n can't be 0 because of the condition here.
yeah.
So you get like 2k is equal to n plus 1, and then n is equal to 2k plus 1, 2k minus 1. So that's just like some odd number. So I guess that was
Oh, yeah.
yeah.
Yeah, you just like do the algebra and you get the exact answer set. That works.
Yeah. But Lainey's thing is like very intuitive. So that's also really nice.
Yeah, depends on whether you're like an algebra person or like I don't know, combinatorics intuitive person. Yeah.
Yeah. Oh my god, my camera's like spazzing out.
True.
That's fine.
And some people were saying like you didn't really understand this question. It's basically saying that like you take any set of n consecutive numbers and their sum is always going to be divisible by n. Like for example, it doesn't work for 4 because if I tried like if I try like for example 3, 4, 5, 6, their sum is 18, which is not divisible by 4, so it wouldn't work for 4. Even if it works for some sets of 4 consecutive numbers, it doesn't work for all, so like 4 wouldn't work. Okay.
Yep.
Well, let's see if we got the right answer. Yay, we did.
Okay. Okay. If anyone has other solutions, also let us know. I'm sure there are like different ways of doing it.
Yeah. We always love different ways of solving the same problem.
Okay, so what's the next one? For a certain value of x, the sum of the digits 10 to the x minus 100 is equal to 45.
Oh, this is interesting.
Oh, interesting. I mean, okay, let's see. So 10 to the x is supposed to be like some number with like a ton of zeros between
Yeah.
it. And then minus 100. And then you get like 0, 0. And then like you like carry a bunch of ones. You get like 9. And then 9, 9, dot, 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 like 9, whatever, right?
Yeah.
Equals to 45. Oh, okay. So the sum, okay, so like so you get like something 999 with like 2 zeros after it. And that's the sum of that has to be equal to 45, right? Okay, wait, which makes sense. So like you got a bunch of nines, which is equal to 45. So that means you got 5 nines, right? So 5 nines. Okay, so I mean, if you have like 1,000, which is you get how many do you get?
Hey, you can
You
just
get
like
one.
try values.
Oh yeah,
Some
that
people
also works.
say, like I don't know, the answer is not that big. So like if you so like I tried whatever this number is, I think 1,000,000, and I got 4 nines, I think. So if I wanted 5 nines, I would just need to add one more zero, I think. And then I would get like 10 million. I guess I could try 10 million.
I got 7, cause like I mean I didn't.
Yeah, yeah, I think I got 7 too. Yeah.
Okay, yeah. Oh shoot. Okay, this keeps moving.
Okay.
Okay. I hope
Yeah.
you can see that. I mean, I like just guessed. Just kind of like guess and check.
Seems like
'Cause
your screen, Angela, is clear. Your face is not, but like your screen is pretty clear.
yeah, my camera is having like issues focusing on my face.
Yeah.
Yeah, it's kind of weird. But I mean, for this problem, you get like a bunch of nines, right? And I tried like a smaller case with 1,000. So like 1,000 has 3 zeros in it, and then you subtract 100, so you get like 1 9. So if x is 3 has 1 9, and you want 5 nines, then you just do 3 plus 4, which is 7.
Yeah.
It takes you out of the smaller case.
Yeah, that makes sense. And also, some people in chat were saying like it makes sense that it's 5 plus 2 is 7 because like you see these two zeros over here, they're created by like subtracting the 100. It kind of like messes around with these two place values. So there's like two weird place values, and then you need like 5 nines. So there needs to be like 5 more zeros. So in total, there's going to be 5 plus 2 zeros.
Oh yeah, that's true. You can just like, yeah.
Yeah.
Oh yeah, so
Though
people.
honestly, for me, like bashing would be more straightforward. But other people, like if they're thinking about it in their heads, that would also work very well.
Yeah. Yes, like have really good comments in the chat.
Yeah. You guys are also smart. Very smart.
Okay, and then what's the next one?
This is
I lost track of who goes first. Wait, I think Vivian. I
I
think this is yours.
honestly I think we're like kind of alternating, but not really because we're like both doing every problem, which is not a bad thing. It's
Yeah.
working.
Okay,
Okay.
so
Well, I think this is like my problem, kind of. Or is it? Yeah, I think it is.
is
Okay,
this
so I think I'm supposed to attempt this problem. So we have two people sitting at non-adjacent chairs, okay? And oh, now they're going to move, okay. So first of all, I'm just gonna like assign them chairs. Since they're not adjacent, let's just say, why do both of their names have to start with J?
I
Okay, I'll
know,
just,
that's what I was saying. I
I
was like, I can't
know.
assign numbers. So I
Okay. They're going to be named numbers now. So 1 and 2. They're going to
J1
be,
and J2.
yeah. I mean, their names are like so similar.
Right?
Yeah. Like they put in effort to make these names as similar as possible. Okay. So in a turn, one person can move to an adjacent chair without a person. Jane moves in the first turn and Gina. Okay, so they like alternate. Oh wow. And how many ways can Gina be adjacent to Jane after 9 moves? Okay, wow, this one seems not easy. Okay, so I guess maybe let's just think about what happens in 9 moves. So 9 moves, since it goes Jane, Gina, Jane, Gina, Jane gets 5 moves, and Gina, or however you pronounce that name, Jenna, gets 4 because like Jane goes first, then Jenna, then Jane, then Jenna. So it's like Jane gets 1 more than Jenna. So in all, Jane gets 5 moves and Gina gets 4. Okay, but I don't think this is very useful. I think I should just like do the brute force and like see what kind of like problem this is, or like how the moves kind of play out. So they start at like this configuration where there's 1 here and 2 there. Oh, wait. Okay. Daphne says Jenna basically has no choice after Jane moves because there's only 1 adjacent empty seat. Wait, you're right. Okay, this problem is much easier than I thought. At least I think. Actually, no, maybe it's still kind of tricky, but at least easier than I thought. So people are saying that Jane and Jenna have limited like ability to like actually move. So first of all, how could the first move play out? Well, person 1 moves first. So let's just say person 1 moves there. Then person 2 would be here. Then wait, let's like quickly make that problem.
That's true. B can only like go like
Yeah.
right after A.
Yeah, and then basically number 2 has like a forced move for like whatever their move is. Like they have to move here. And then it's like, and then person 1, oh wait, okay, DW, you literally just summed up the entire thing in the chat just now. Jane has 2 moves always, while Jenna has 1 move always. Wait, that literally is mind blowing. That's actually so cool. So, and you might be wondering, like, why is this true? Well, let's say that the configuration was like this, then clearly person 1 has 2 choices. They can either move here or here. So they have 2 choices. Now, wherever they move, person 2 will have to move here because that's their only adjacent place. Just like Angela is writing on her screen. So like, and then guess what happens once person 2 does their move? It becomes like the same configuration as it was in the beginning, but just like rotated, but it's the same thing. So overall, basically, Jane always has 2 choices. Excuse my bad handwriting. Jenna has 1 choice, and then it's just a multiplication problem, I think. Yeah. Angela, do you have anything to add?
When it asks for like 9 moves, it's 9 moves for both of them, right?
Yeah, I think 9 moves for both of them.
Okay, so the question is how many times could they be adjacent? I mean,
Oh, wait, they have to be. Wait, do they like are they always adjacent after 9 moves though?
I don't. That's the thing, because in this one,
I'm
yeah,
pretty sure they are always adjacent after 9 moves. Because like there's only 2 different configurations, them being adjacent and them not being adjacent. And in the configuration of them not being adjacent, this is always after even number moves and the configuration of them being adjacent, that is always after odd number of moves. So if it's after 9 moves, I think it's always going to be the second configuration because it just flip-flops between the two configurations, I think.
I see. Okay, so if it keeps, so after each configuration, it flip-flop to the same configuration.
Yeah, like it
Then,
flip-flops between adjacent and non-adjacent.
like this, right? Like, so like A would go, for example, like to the right only. It would be like here and then here. And then B goes and then it would be like here, right?
Yeah, so like every other configuration, they're opposite, and every other configuration, they're adjacent.
Oh, I see, I see. Okay. So they're going to be adjacent every time A finishes, and A finishes 5 times.
Yeah, I think that's it.
So like every one of these, like A here and then A here.
Yeah.
Okay, so A moves 5 times, and it can either go left or right. So like each case
So, but it
would.
has 2 choices every time, and it gets to choose 5 times. Okay, yeah. People in chat are saying like the correct things. Yeah. So Ray is saying, first of all, like right, right, left is different from right, left, right. Yeah, that is like a key part of the problem. Like we're counting every choice that like every person has. Like we're counting their first choice being right as different from like their first choice being left. We're counting like all the possible combinations of what all of their choices could have been. And yeah, and people are also saying like 2 to the power 4 or 2 to the power 5. I see exactly how you got that. So basically, this is like the key idea that Jane has 2 choices for each of her moves. Gina has 1 choice for each of her moves. So by like whatever this multiplication principle is, we basically just multiply the numbers, like the numbers of different choices that each person has on their moves. So like this 2 right here corresponds to Jane's first move. She has 2 choices. This 1 right here corresponds to Gina's first move. She has 1 choice. This 2 right here corresponds to Jane's second move, and so on. We have 9 moves in all. So yeah, since Jane moved first, it would just be 2 to the power 5. Since Jane has 5, like she chooses 5 times.
Yeah. So like, okay, so like in my drawing, like I have different configuration. Notice that this is opposite, and then the next one is also opposite, and then this space is adjacent, and the next spot is adjacent. And you know that like they're gonna be adjacent every time after A moves, right? So A moves 5 times, so it's gonna be 5. I don't think it's. I think it's gonna be 5, not 4, right?
Yeah, I think it's going to be 2 to the 5. And this is another like diagram for why it would be 2 to the 5, because so consider these 5 like layers of this like tree kind of thing. In each of these 5 layers, Jane has like 2 choices, either left or right. And whichever combination of like 5 lefts or rights, each of those 5 times she gets a choice, there's like 32 different options of what it could end up being. It's kind of like a visual representation.
Yeah.
Anyway,
And oh, sorry. Oh, if you're like curious why like you can do like it doesn't matter which, and if you're curious like why my drawing doesn't take into account like left or right, it doesn't really matter, right? So like let's say we have this ending configuration and I made like A go right. But like if A went left instead of right in my drawing here, it would still be adjacent, right? But it would just be adjacent at the opposite side. Right. So it doesn't really matter because it would still end up in the same configuration no matter which side you choose to pick.
yeah, exactly. So we're just kind of like dumbing the problem down to just 2 main cases. Like instead of 4 chairs and like 2 people and all this complicated stuff, there's only 2 really like 2 fundamental different configurations, either opposite or adjacent. Opposite is where the 2 people are opposite. Adjacent is when they're adjacent. And we really only care about these 2 like configurations because they determine the number of choices that each person has of of how many like empty seats are adjacent to them. Oh, we're assuming that the chairs are indistinguishable. That's true. I mean, I think, wait, are you sure? I think we might be assuming that they are distinguishable. Wait, hold on.
I think if we're taking account like adjacent versus opposite, they would be distinguishable.
Yeah, I think they are distinct because like the 32 comes from multiplying together all these twos. So it should matter like whether Jane moves to like the top chair or like the bottom chair. That should matter, I guess. If it didn't matter, then the answer would be like 1 or something, right? Because like, or
It
like
would be a lot
4.
smaller.
Yeah, it would
Yeah.
be a lot smaller. But
Yeah.
anyway, I'm assuming that they're like different chairs.
Okay, my camera is like spazzing out. Okay. I think we should be fine for this one, right?
Yeah. Okay, let's see if the answer is really 32. I swear if it's not. Oh, phew, it is. Yay. Let's go. Wait, oops, you guys can't see this. There.
Ways dot so many chair placements.
Yeah, wait. So that makes sense.
Mm-hmm. I really like whoever like wrote this problem. I think that's
Yeah, whoever wrote this problem is very big brain.
yeah, because it's taking
Very
advantage
cool.
of the fact that it's 4. Like if the answer, if it wasn't 4 chairs, I think this would be a lot more difficult.
Yeah. And there's somehow like a symmetry between opposite and adjacent. That's very cool. Okay, what's the next problem?
It says Jerry and Aaron both pick 2 integers from 1 to 6, inclusive and independently, and then tell Dennis their answer.
Okay.
Aaron's number is at least 3 times. Okay, so at least we know that Jerry's number is less than Aaron's number.
I mean, we could like technically like write out all the possible cases of what Aaron's number and Jerry's number are. Like if we were really brain dead, we could just write out all the possible like possibilities. There aren't that many.
Let's see. So if Aaron, wait, listen. I think we should start with Jerry because like the only way that like
Yeah, Jerry's number would have to be small.
yeah, like I feel like the only way that Jerry would know the number is if at least 3 times Jerry's number is like greater than 6. You know, like there's some type of cap to like 3 times. And he's like, oh, it can't be like greater than 6. So it must be like something within that range. Oh yeah, Vivian's writing out the choices. Yeah.
Wait, so okay, Aaron says I still know. Oh, okay, I see. Okay, I see. Yeah. So if you just like write out like all the possible like things, Jerry must have 1 or 2 because if Jerry has a number bigger than 2, then at least 3 times Jerry's number would be more than 6, which is impossible because Aaron has a number above 6. So these are all the possible like options. It could be 1 and 3, 1, 4, 1, 5, 1, 6, or 2, 6. And then so this statement about Aaron not knowing Jerry's number implies that, well, because Aaron knows his own number, right? So Aaron must have a number for which there's multiple different things Jerry could have for that number. And yeah, okay, you guys are all saying it has to be 6. Excellent explanations. Yeah, you guys are basically all saying the same thing. If Aaron had any of 3, 4, or 5, he would know immediately what Jerry's number is because there's only one possible thing it could be. However, if Aaron had 6, there's 2 different things Jerry could have. So he obviously doesn't know. And then, okay, now we want to know the sum of their numbers. Wait. Oh. Okay, wait, so there's another layer to this. Okay, wait. I see. Okay, so clearly we know Aaron has to have 6. And then Jerry replies, oh, now I know Aaron's number. Wait, hold on.
I'm getting their names confused.
Oh, yeah, me too. Okay. Wait, they both pick 2 numbers?
Wait.
Oh, wait, no, they each pick 1 number, right? Okay, I got confused there for a second. I was like,
wait, I was under the impression that Jerry must be 2. Right?
Wait, I don't actually know what Jerry is yet, but I'm pretty sure Aaron is 6.
Because if so, like
Oh, wait,
if Jerry is 2, then
uh-huh.
like it says at least 3, right? So it's either 3 times or 4 times, but like you can only do 3 times because then it's out of the range of 1 to 6.
Yeah.
So
Wait, but isn't it possible that Jerry has 1 and Aaron has 6?
Jerry has 1 and Aaron does. If Jerry has 1, then he can guess that Aaron has either 3, 4, 5, or 6. Right?
But he doesn't know, right? Wait.
He does know, but like
Yeah, but that's because Aaron said. I still don't know Jerry's number. So the fact that Aaron said that eliminates 3, 4, and 5. Because if Aaron had 3, 4, and 5, he would know what Jerry had. So Aaron has to have 6. Then
Aaron has to have 6.
wait, okay, do you guys agree that Aaron has to have 6? It seems like people agree. Wait.
Oh,
Okay.
that's true. If Aaron had 6, then he would know from the start that Jerry had 2. So that would work out because then they both would know their things. Okay. I think this wouldn't work. I think it's either like I think it's 6 and 1, right? Aaron, because you said Jerry had 6.
Yeah, I have a feeling it is 6 and 1. Like using the fact that this says now, like if it didn't say now, I wouldn't know. But since Jerry's saying now, I know Aaron's number. Like if it was 2 and 6, Jerry would have known from the start, like what people are saying, because there's only one like combination starting with 2. So I kind of agree. Should be 1 and 6. I think.
Oh, it should be 1 and 6 because it says now. Oh, I get it. Okay.
unless we're like reading this wrong or something.
Okay, yeah, I think
Oh my gosh, wait. Dash and dash has a point. If it was 6 plus 2, it would be 8. Yeah. So I guess it's either like 7 or not enough info. What do you guys think? I have a feeling it's 7.
I mean, also the letters are like D and E. D and D.
Wait. Okay, let's just bubble D on the answer sheet and get it right.
This is like D. I think it should be 7, right? Because like if I was Aaron and I was like, I have 6, and then Dennis is like, Aaron is like, I don't know, because if Aaron is 6, then Jerry could either be
1 or 2.
1 or 2, right? So he's like, oh, I don't know what it is.
Yeah.
And so Jerry is like, oh, then his number must be 6. Wait, no.
Yeah, because like Jerry is smart, and Jerry knows that like whoever A is, Aaron would only say that if they had 6. So like Jerry knows, oh, Aaron must have had 6.
Okay, yeah, okay. So it's 7 then.
Yeah, okay, let's see.
Just pick D. It's like we can't be
Yay,
wrong.
it is 7. Okay. Yeah, the answer is just D.
D, which is no, my pen. Okay.
Yeah. How's alpha and beta? Okay. Alpha and beta. Well, wait, I guess I'm attempting this problem. Oh yeah, I got another geometry problem. Let's go. Okay, so we have this rectangular fence, 8-meter ropes to the midpoints of adjacent sides. Okay, let's switch to white. And then they wander outside the fence. Oh, this is going to be like one of those problems of like how far can they like wander? Anyway, okay, so they're both outside the fence. Alpha can wander in a region with area 34 pi, and beta can wander in a region. Oh, okay, interesting. Wait, there's a diagram on the next slide. Okay,
I think there's a diagram all the slides.
Oh, seriously? I thought it was okay. I guess it's not a very useful diagram. So, okay, so we have one area with 34 pi meters squared and one area with 40 pi meters squared. Okay, I have a feeling like the areas that they can wander in are going to look something like, not exactly this, but they're going to be like, yeah, Lainey is saying, like, I get what you're saying. So Like once they touch the corner, the shape changes. So like you don't know if their shape is going to be this or this or like this. Like it depends on how big the radius of like however far they can go is. Oh wait, chat mod, you are really smart. You can figure out the area of a half circle since they gave us a radius of 8. Okay, so you know what? I just realized, like, looking at all three of these like weird areas, which one do you think could be 34 pi or 40 pi? Like, two of them, at least two of them, the outer two, don't look like they are nice numbers. Like, how in the world are you supposed to find the area of something that looks like this? Like this. This, I don't think that would be a nice number, like 34 pi. So I'm gonna, like, I'm pretty sure that, wait, hold on. Am I like doing this wrong? Okay, I'm pretty sure like the shapes are going to be at least somewhat nice. But yeah, okay. Oh, wait, okay. You guys have really smart ideas in chat. So Ray says that the area of a half circle with radius 8 is 32 pi, right? And they're both bigger than 32 pi, which means that like you see this pink half circle right here, it cannot be the pink half circle because it's more than that. In that case, I was wrong initially about like it not, yeah, I was kind of going the wrong direction, but okay. So it clearly has to be more than the half circle, which means it's going to be something weird like this, I think. Wait.
Do you think it's gonna be like, oh wait, no, it has to cross both corners, right? Like
Yeah, it
both.
has to cross both.
Okay.
Oh, okay. Ray is saying the shape, if it crosses the corners, is a semicircle plus 2 smaller quarter circles. Okay. Wait, so are you saying that like if you draw this line right here, then like the part to the left of the line is the semicircle, while the wait, okay, wait. I was drawing this completely wrong. You know what? I'm going to get a bigger diagram on the next page because I think that's a good idea. So yeah, I completely forgot that rope bends, but that is definitely a fact. So rope bends, which means that this is actually a much nicer problem than I thought. It basically looks like this with the 2 quarter circles. Okay, now I get what you guys meant by like 2 quarter circles. Okay. So this is like the distance that one of them can roam. Oh, wait. Yeah, so okay, so this is the distance, this is like the area that one of them can roam. And we actually know, wasn't the radius 8? So the radius is 8, which means that like this is 8, and then actually wait, I'm going to use some like variables. So let's say that this part out here is x and this part is 8 minus x, then this thing would have area 1/2 times 8 minus x squared plus half times x squared pi. Okay, so we get an ugly equation. Cool. Oh, wait. Oh, wait. Hold on. This is much less ugly than I thought. Wow, I'm doing it. Wait, I actually did this wrong. Hold on. It's actually not that. It's actually half times 8 squared plus x squared. Okay, that's much better. Yeah. So it should actually be half times 8 squared plus x squared pi. And then, so, okay, so Ray is saying like, suppose that this area was 34 pi. If this is 34 pi, then we would get x squared equals 4, I think. And then x equals 2, I think. Yeah. We are definitely overcomplicating this. Like, no kidding. I'm definitely overcomplicating this. Like, I did not need the variables. Why did I even put the variables there? Well, you know what? Since I already found out like the value of x, I'm just going to like erase this and draw like a better diagram.
Yeah, x is 2, but
Yeah, x is 2, isn't it?
that's assuming it's 34 pi.
Yeah, exactly. So we're not even sure if like the smaller circle or like the smaller area is on this side or on the other side. But
Does it
like,
really matter though? Like
hmm.
it's like variable. It could be either side. Like
Yeah,
yeah,
well, one of the sides has more roaming area than the other. And I actually feel like wait, yeah, I feel like the smaller area would be on the longer side, right? Because like
oh, that's true. It would be on the longer side because
yeah,
the rope won't reach.
so actually, wait, so actually we know that the semicircle is 32 pi, which means that the sum of those two quarter circles, which would have to be 8 pi, because we have 40 pi and 34 pi. So actually, sum of quarter circles equals 8 pi. Therefore, each have radius 4, I think, because then like the sum of the two quarter circles would be half times 16 pi, which is 8 pi. So actually this thing right here is 4. And then would this work? Like, wait, oh, and then this one would have to like go over. Wait, yeah, you know what? I'm going to see what the question was asking for again. The area enclosed by the rectangular fence. Okay.
Wait. Well, if you like assume that both of them have like those corner areas, it does work out nicely.
Yeah, wait. Angela's diagram is correct. Wait, yeah, that's literally the correct diagram. Like mine is really not like to scale, but yeah, we basically just have to solve for like the parts that it hangs off by, and then we can just like.
Okay, they picked like nice numbers. I'm assuming this
Yeah,
is
they
like.
are nice numbers. Yeah, they are nice.
Wait, what was the question again? What's the area?
It's the area of the rectangle. We want to find the area of the rectangle.
Okay. Okay, so this is like such a terrible like my diagram is so ugly. Sorry. So this is we established that this is like 2, right? So this is 4. And is the area on the shorter side? Yeah, so sorry for pronouncing your name wrong, but Neha, she said that the area of the circle on the shorter side would probably be 40 pi because like if you think about it, like if the thing is only 8, then when it cuts these corners, it's gonna cut like more like a wider area than like this longer side. So my diagram is kind of flipped. So imagine like the smaller one is 40 pi and the bigger one is 34 pi. I kind of flipped it here. But yeah, you make a really good point. So just imagine it's flipped. Sorry.
Okay. Wait, I'm pretty sure like I'm pretty sure this is a better diagram. Yeah, Ray is saying the rope extends over the corners more for short sides than long sides because like if the side is short, the person or the horse or whatever has like more freedom kind of because there's less obstruction. So yeah. Wait, okay. So I guess now all we have to do is solve for the sides of the rectangle. And I think like because these two quarter circles had radius 2, I'm pretty sure like that means that this side of the rectangle is 12 because it's 6 plus 6 and like the radius was 8, so this is 8. So then like the part left over after subtracting out the 2 is 6. So yeah, and then you do the same thing for the short side. Oh, how did we get 6 for the sides? So like the radius of the circle is 8, and then we kind of solved for like this little radius x. By the way, as a recap, the way we solved for that x was noticing that like, so this semicircle up top was 32 pi. But then we had some little bits to add on that make it in total equal 34 pi. So 2 quarter circles equals 2 pi. And then we just solve, wait, no. Yeah. So we just solve this equation, and then we get half times, just pretend that this circle is like all four, like 4 of those quarter circles put together. So half of this equals 2 pi, and then we just get radius 2. So that's how we got the 6. And then, yeah. How did we find which one was 40 and which one was 32? Okay, so yeah, we had to figure out which one was going to be on the longer side and which one was on the shorter side. But we kind of thought that the one on the shorter side would probably have more area, because picture you have like a circle, right? And then you have something like blocking part of the circle. If it's small, then it's not going to block much of the circle, right? Because like it's not going to take up much area. However, if it's big, then it takes up a lot of the circle, right? So like the small side, whichever circle kind of, or like part of a circle is on the small side, should probably, it's not even a perfect circle, but like intuitively the small side should like yield more area. Also, like you could do it mathematically. Like there's a bit of like rope that kind of hangs off the side, and for the small side, this like orange bit of rope would be more, because you're taking 8 and you're subtracting this 4, which is less. Meanwhile, for the big one, for the big side, this like bit of rope hanging off would be less. So to create more area to roam, you want a bigger like orange piece, which means a smaller side. Yeah. So, okay, so I guess the area, wait, yeah, what? You can go.
Oh, no. Your diagram's a lot better. Go ahead with you.
I mean, yours is also like really good too.
Mine is like inverted. I have to like redraw it. I think yours is probably going to be a lot clearer.
Okay. I mean, we're basically done with the problem. I think it's just 8 times 12 equals 96.
Yeah, I got 96 too.
Nice.
Okay. Yay. I think the hard part about this problem is figuring out that like the thing is bigger than the actual like square.
Yeah. Because like I spent a while thinking that they were going to be semicircles, but no, they were not.
Okay, let's check the answer.
Yay. It is 96.
Oh, yay. Okay.
Nice.
I think I have one less problem, which means
probably we have enough time for one more. And these are not easy problems. Like don't feel bad if you did not solve them, because they're not easy at all. Oh, and if people have questions about like other math contest general things, you can ask them afterwards, and we will like do our best to answer them. I think I'll be able to stay for like a few minutes after. But for now, let's try to cover one more problem. Let's try to like do this one together, so it will not take too much time. Oh, this is interesting.
I love the name Elax. It's like relaxing. You're like, oh no, let's
wait, hold on. Relax. Like a cross between Eli and like relax.
They're like, yeah, let's just, we ran out of names, you know. They got Jane and Gina. Now we got Elax. Okay. What was it? It's a partially filled 4x4. Oh, okay. So it's not a magic square. It's not a magic. Okay.
Oh, okay. Any 4 cells that share no rows or columns sum to S. Okay.
Yeah. Okay. So yes. So N dash in the chat said the 4 cells are the diagonals. Yeah. So the diagonals are definitely like one case in which that works. Oh yeah. Ray also said 8, 7, 11. 4.
Yeah, that's smart. You can literally just find S right away.
True. Oh yeah. So this works. So like these 4 numbers that they already give us don't share any rows or columns. So these are good.
Yeah.
What else? That is 30? I think 30.
Yeah, I think it is.
Okay,
I would, okay, yeah. Hamad is saying you can get the bottom left number. Okay, let's see. How would you get the bottom left number? let's just erase these circles quickly. So yeah, I would just try to like go and get as many numbers as you can. So the bottom
Oh,
of
you could do 8,
oh,
7, 9.
I see. Okay. So that would be just 30 minus 8 minus 7 minus 9, which is 30 minus 24, because like it's 8 times 3 basically, so that would be 6. Okay, cool.
Oh yeah, we got more numbers. Okay. What else can we get?
This is kind of fun, honestly.
I think we can do the third column, second to last one.
Yeah, I think that too. Yeah. So if we do the 10, 8, and 4, we get 30 minus 10 minus 8 minus 4 equals 8, I think. I can do math.
Yeah, I got 8 too.
Okay, nice. Oh, and the number next to 4. Oh, okay.
Let's go. We can get the number next to 4. Oh, we can.
Wow, erasing takes so much time.
I'm gonna erase some of my work. So 8, get that one.
Okay. So yeah, 10, 8, and 9, and then we would get 30 minus 10 minus 8 minus 9 equals 3. I think 3. Okay.
Wait, 18 to, oh yeah, 3, so that's 3.
Okay.
Okay.
Oh, the next one. Okay. Oh, okay. So we should like we want to get this number, right? But anyway. So which number can we get next? The number above the 9? Okay, let's see. Number above the 9. So we could pick 8, 10. Okay, yeah, I see. We could pick 8, 10, 8, 11, and 3.
Wait, 8, 11, and oh yeah. No, right, yeah, you're right.
So 30 minus 8 minus 11 minus 3 equals 8.
Wait, 11, 8, and which one? 4?
11, 8, and 3.
11, 8, and 3. That would, wait, how would that work? 11, 8, and 3.
You mean like, wait, hold on. Am I doing math?
I don't think you can get any of those, like the top right corners of that. Oh yeah, okay, yeah. So I don't know who chatbot is.
Wait, I'm pretty sure like they were saying you can get this one from doing the 11, 8, and 3. Like the fourth one. Like the yeah, the second row last number.
I don't think you can get that one.
Wait. I think you might be looking at the wrong 8, but like it's the 8 next to the question mark. And then the 11 and the 3.
11 and oh yes, okay, I am.
Yeah, there are so many 8s. It's so confusing. It's okay.
Okay, so that would be 8, 19, 22. That would be another 8.
Yeah, I know.
Okay, well that's a lot of 8s.
Yeah.
Okay, we're almost there. You can get the number next to 6. Where's the 6? Oh, that one. Let's see.
Okay, let's see. Oh, how would you get that one? You could do like 11, 8, 8.
11. Wait, which 8?
Wait, no, never mind. That 8.
Like, which 8 are we talking about now? The other, like, which of the 3? The top 8 has, so it's hard. Besides, maybe it's very.
Wait, actually, are you sure you can get that number? I don't know.
I think you can get the number. I think. Okay, I think personally the issue here is that if you want to fill in any of the numbers currently, like you can't fill up any of the top numbers because the 8 is there, and you can't fill out any of the numbers below 8 because.
Oh.
So yeah, I think that's.
Wait, okay, I see why some people are saying to like use variables.
Yeah.
I guess.
Okay, I'm gonna.
Actually, go ahead.
I want to start using variables. Who is chatbot? I'm so confused.
I don't think it's a real chatbot. Okay.
I'm gonna start using variables then.
Yeah. All right.
I'm just gonna guess in chat at this point.
I'm pretty sure you can get like all three of these numbers using A and B. It's really confusing how I'm writing X there. Like, so
Yeah. Oh, I see what you're saying. Okay, so question mark plus B plus.
Oh wait, one variable is all you need. Okay, I'm going to erase B and like only use A and like see what I can get. So this number on the bottom, that would be 30 minus A minus 10 minus 9 equals 11 minus A. So I guess this would be 11 minus A. And then the one on top of that would be 30 minus A minus
A the top plus
10 minus 4 equals 16 minus A. Honestly, is there like a better way to do this problem than just like bash it? No,
I don't really know. We have question
sure.
mark plus A. I have question mark plus A, question mark. Oh wait, you don't have my variables. Oh yeah, never mind. I'm like,
well, let's see if we like kind of get the same thing.
Yeah, okay, yeah, we can try different ways of getting it.
Minus 9
plus, so we can try
15, right?
11 plus A plus C plus A plus C plus 4. We get that. 11 plus A plus C plus 4. So that's A plus C is 15. So we have A, B. Wait, I have A, B. I have C, D. I have A, C. Oh, goodness.
Okay, let's see if I can even solve the problem.
Oh, wait. Okay, we could try 6 plus B plus 7 plus D is 30. And then B plus D is 17. Okay, I might be getting somewhere with this. Gotta make the work smaller now.
Oh, yeah.
So so like something like this, right? I think you were referring to the top row. I think this was my top row. It was question mark plus C plus D is 22, right? Eight and a 4. Okay. Okay, yeah, this one. D plus A. Okay, I don't have D plus A, but I think you're talking about this one, and then this one and this one, right? 18.
Nice.
I see. No, I think that's like I think the problem itself is like it's supposed to be using variables, right?
Yeah.
I think that's the only way you can do it.
Yeah, like you should definitely be able to do it. Like there's definitely enough information.
Yeah. Okay. I think I have some like I have A, B, C, D, right? I have A plus B plus C plus D is equal to 32, right? And I have A, B, C, D here. So A, B, C, D here. So that's 3 question marks plus A, B, C, D. A plus B plus C plus D equals 40? 40. Wait, no, that's not 40. That's 54, right? 54, 32, 18, 32, 54. Yes, okay, so 3 question marks is going to be 18. And so question mark is 6? No, I don't think that's right.
Wait, hold on.
If you can find out what AB, then you can easily. Yeah, I think that's I forgot who was speaking earlier, but I think that's how, like, I think that's the plan, like to get these variables down and then find some way to arrange them. I just don't know what I don't think it's 6, is it? It's
Wait, that's so weird though, because 54 minus 32 is 22.
4, 18. Oh wait, no, I added wrong. Oh my gosh, what's wrong with me? 54.
It's okay. I mean, adding is hard.
Adding is hard. It's
It's an
22.
8. That's so weird though, because then question mark is not an integer. Wait, hold on.
Yeah. Wait, does anyone know what I did wrong? Is that the top
I'm
left?
trying to.
Okay, I think chat mod used something similar to Vivian's work. But I think this works. I think I added wrong somewhere. Like
Yeah.
11.
Wait, is it the first one? Oh wait, never mind. That's an 8, not a 3.
Oh, I see where I went wrong. This is 19.
Oh. Okay, so
Okay.
then it should be 37 plus 22 is 59. Okay, it should work now. Yeah. So instead of 52, 59, and then it should be 27. Yay, that's what I got too. Nice.
Okay, yay, okay. We finally got something.
Oh, finally. Okay.
9. Okay. Yeah. Chat mod has some really great comments. I think they did a different way. Like I had different variables than them, but so the last number is
yeah, I think it works with like any number of variables. They just all like somehow end up canceling out. But you can do it any way you want.
Okay, so there's different. I think there's definitely different ways of doing this.
Yeah.
This is like kind of ugly and atrocious, but
I mean, it kind of makes sense. Like it's intuitive.
yeah. Okay. Well, I think that's the last one, right? Wait.
Yeah. We're kind of like 10 minutes over time. But
sorry about that.
Yeah, sorry. We hope you guys enjoyed this. And these were some really interesting problems. Thanks to the organizers for making them.
Yeah. Yeah, thank you for the organizers. I think these problems are really well written. I was like,
yeah, especially the name, like ELAC, like that's a high quality name.
I think MIG just like student run, right?
Probably.
I think that's like these are some really nice like. Can you imagine creating this ELACs problem? I like can't imagine doing it. Yeah. Yeah, everyone, thank you for coming. We're sorry that like it went a little bit over. It's just me and Vivian like stumbling through our variables.
Yeah.
Yeah, but we hope you enjoyed it. And thank you guys for coming. I hope you guys had fun because me and Vivian did. Yeah.
Bye. Thank you so much.
Bye. Thank you for coming.
Thank you. Thank you all.
No problem. I think we're gonna stay a little bit over. Yeah. I think maybe we're gonna stay a little bit.
Yeah, I think we'll stay like a few minutes or something because some people might have questions. Also, if the organizers are here, then like.
Oh yeah, if the organizers are here.
I don't know. Maybe we can like chat.
Yo, I think chatmod is chatmod Professor Lowe or.
Wait, hold on. Chatmod is not Professor Lowe, is it? I kind of.
Is it Debbie? or
Wait.
Emily, or
Okay, Chapman is definitely not a kid. Why did I only just realize this? Wait, it's probably another TA. Wait, hold up.
oh, what if it's Eddie or Shankar or Eric or
Wait,
Aubrey?
hold up. Oh my gosh.
Because they
Okay.
were making like suggestions. I was like, Chatmon is really good. Like,
Oh, like, wait, Chapman knows what's going on.
oh, interesting. Maybe they'll reveal themselves later.
Maybe, yeah.
Okay. If you guys have like any other questions, maybe like not this problem related, I guess we can also talk about that. But yeah.
Oh, it seems like people are just hanging out in the Zoom meeting. Hello.
Oh yeah. Sometimes me and Eddie like we hang out after class to like talk about nothing, and like people like eavesdrop.
Wait, that happens in my class too.
They just like listen to me and Eddie, and like one time a parent came on and he was like, "I have a question." Like,
actually, wow.
Yeah, no, they had a question about like they had some trouble with the website, but they were like, "Hey guys, sorry to interrupt you, but I have a question." And then after we helped him with the question, he was like, "Oh yeah, you guys can go back to talking." And I was like, "Oh no."
Wow.
Yeah.
Funny.
Yeah. So if anyone has any other questions.